Hello, how are you? So let's talk something about calculus today. The concept of differentiation and integration, but without going into any real mathematics, any calculations, any formula whatsoever. Rather, we will take a very practical approach. Say a car starts at a point A, it then speeds up and then stops at a point B, which is 100 meters away, and this all happens over a course of 10 seconds. We can plot this journey by taking time on the horizontal axis and distance travel on the vertical axis. And we are interested in calculating the velocity at a moment. Now you may say that velocity at a moment is whatever the speedometer of the car shows at that moment. Is it not? But hold on. Velocity at a moment makes absolutely no sense. Say for instance, what if I take a snapshot, a picture of a car moving at a moment and show you and ask that could you please tell me how fast the car is moving? I think you have absolutely no means to answer it, because we need at least two distinct points in time so that we can compute the change in distance by change in time, and that's velocity for you. Now, you may argue that if this is so, what actually the speedometer of the car shows? So let's try to find out what probably the speedometer might be doing. Let at any point, say 3 seconds into our journey, the speedometer of the car might measure the distance traveled by the car in a very tiny moment. Say it measures the distance from between 3 seconds to 3.01 seconds, and it can then compute this distance traveled by the tiny time interval. So what I want you to infer from this is that any physical car does not measure velocity at a given moment, but rather over a small interval of time. So that's very important for you to understand. And as this small time interval approaches to zero, the ratio of the change in distance by change in time approaches to a quantity which is known as derivative. And mathematically, as this small time interval approaches to zero, the ratio of change in distance by change in time approaches to slope of a line which is tangent to the graph at whatever point we are looking at. So hope this clears the concept of differentiation. Now let's take a different scenario. Let's go back to a car which is still waiting for us. So get inside the car, and now you're not allowed to look outside the windows of the car, and all you can see is only the speedometer of the car. The car starts again, it speeds up and then stops again, and this all happens over a course of 10 seconds. Now the challenge for you is there a nice way to figure out the distance traveled by the car by observation of the speedometer alone? Now let's make it a bit simple. Say if the velocity of the car was constant, the distance traveled would have been equal to the product of the velocity and the total time elapsed. But what I want you to appreciate is that this distance traveled is equal to the area under the velocity time graph, given the velocity is along the vertical axis and time is along the horizontal axis. Now, with this idea at the back of our mind, let's go back to our original situation where velocity is changing at every instant. But anyway, we need to find the area in order to calculate the distance. So what can we do? Okay, so why don't we chop up the entire time axis between 0 to 10 seconds into very tiny time intervals, say dt. dt might be of the order of say 0.001 second. And dt is so small that we can approximate the velocity in this small time interval to be constant. And the reason for doing this is that we don't know how to handle situations other than constant velocity ones. So what I want you to appreciate is, to visualize is, that the entire curve can now be seen as composed of very tiny small rectangular strips. We can calculate area of each rectangular strip, that will be equal to velocity into dt while velocity for all the rectangular strips will be different. Now as dt gets smaller and smaller, our approximation gets better and better, and as dt approaches to 0, the sum of areas of all the rectangles approaches to a value which is equal to area bounded by the curve and the horizontal axis, and this is our distance. This is the distance traveled by our car, and that's integration for you. So hope you were able to understand the concept of differentiation and integration